Hello, my brother.
Charles.
Hey, how you doing, bro?
How's it going?
Yeah, good. I got all the bits and pieces together, and
Nice.
we've got like some big old meters measuring stuff. I'm just trying to. Unfortunately, it doesn't look like the this tape of LEDs. It's got a 1 watt, I think, impedance limit. It says it needs minimum of 1 watt, and we've got 500. I don't know. I'm not sure we have enough, really.
So you have it set up now. Is your potentiometer turned all the way to the right?
Yeah.
Now slowly turn it to the left.
Oh my gosh.
Slowly. And not all the way over. Is everything plugged in?
Yeah. Oh wait, the output. Yeah, no, that's coming out. The output. Let's see which way have I done that. Red, green, and black. Yeah, I put the green one in the middle. I've left hanging out. I'm turning the potentiometer to the left. Let me hook up my little measurement device. Where should I measure? On the output?
Yes.
I'm getting 555, 550 now because I've turned the potentiometer up.
Millivolts?
It says milliamps. On volts, everything with a V on it, I'm just getting it's the same. It doesn't change, input or output. But on amps, I'm getting amps.
Well, you have to take that off now. Please unplug it as quickly as possible.
Okay.
Why? Because you don't want to close the output leads together with. So when you do that, what you're doing is basically just connecting them to each other.
Yeah.
Through the meter. You don't want to do that.
Okay.
You want to measure voltage with that same meter. Switch over. I think right now your red pin on the meter that you're holding in your hand is going into amps. So you have to switch it over to the right.
Okay.
There you go. And then what you're going to do is switch it now to volts to measure voltage.
Yeah.
And it should be alternating current. So you should see the squiggly line, not a straight dash.
Yeah.
All right. So now go ahead and plug that in again.
What, onto the output?
Yes.
.1 millivolts.
And now, is that turned all the way to the right?
Yeah.
So now, if you can, just hold it to me and turn it slowly to the left.
Can you see?
Yes, I can see. So you're turning it slowly to the left right now, right?
Yeah, very slowly.
And that's pretty much...
It's going crazy now.
Yeah, that's not... What was that? What was that?
I just turned it back the other way. So we got 2 point... No, it's not really very stable. So I'm turning it all the way back to the right. Oh, it keeps going and going. Okay, now it's all the way back to the right, 0.1. Turn it a little bit. 0.
Okay. Well, I just went back out to Radio Shack and I got some more of these TIP transistors. So the little demo, I'm gonna plug it in here and just run it side by side to what you're doing there.
Okay.
Because yeah, you should be getting a voltage reading on the output there. So let me just plug in my voltmeter. You should definitely be getting an output voltage.
What was the amp reading that I was getting?
The amp reading, you were basically, I don't know if now because you did that, you may have fried that transistor, because basically what you did was you connected the collector to the emitter. So you connected the positive of the transistor directly to ground, and that normally fries transistors.
Okay.
So I don't know if that might have done that, but We're gonna find out right now. So I'm just gonna check my my voltage on the output and show you what you should be seeing. Yeah, you normally never want to if so how you do that, if you're gonna measure output amperage, you basically take the red pin of your multimeter and connect it to the collector of the transistor, right? Directly. And you go through the unfused portion that you were in before. So then your black pin actually becomes like a positive. You see, so then you connect that black pin to the positive of the LED strip, and then the negative goes to ground. So you never really measure amperage going directly into the source like that.
Mm.
So it's all right. You know, it's all a learning process too. We've
Fortunately,
blown many of transistors, brother.
I bought many transistors.
Amen.
Yeah.
They'll come and go. All right, so this is what I'm seeing here.
Swift.
Can you see?
It's a bit dark, but you've got a stable thing there.
Yeah, so I'm gonna tune it now. I'm gonna tune it, and you're gonna see the voltage, and it should increase. So I'm turning it slowly to the left. Slowly to the left, and it's actually going down. But anyway, it is stable. It is going down though. Now let's go ahead and take that same output and plug it into like a standard type of these LED bulbs. So I'm just gonna grab these Christmas bulbs that we have over here. Drop a few things in the process. All right, so these are the standard LED bulbs. So I'm gonna go ahead and plug this directly into the output. So right there where I was measuring the voltage, put the positive, the negative. You see those bulbs?
Mm-hmm. Way.
So now I'm gonna tune it.
That's great. So can you show us what it looks like when you crocodile clip those directly onto the power source that goes in?
Yeah, so this is, so instead of running the meter,
Yeah.
just directly into there.
Yeah, I mean, can you unclick it from the end of from the output of the coil and click it onto the input that you're putting into the coil so we can see the difference in brightness?
Oh, so you want to just, okay. So let's go like this.
Yeah, and just clip it straight on the battery.
Now we'll take this and go straight to the battery. Nothing. It's not supposed to turn on, Charles. It takes 120 volts to turn it on. It's not going to turn it on with 12 volts. So it's never going to light like that by itself.
Really?
No, never.
Oh my gosh.
You need to run an inverter, and inverters, they waste a lot of energy. So yeah, just creating the oscillation, we're replacing inverters altogether to run lights, making lighting more energy efficient.
Beautiful.
Beautiful.
Beautiful, man.
So now there's another setup that I've been running here, and let me just show you that really quickly. So this is the setup we were running last night.
So can I just run and hoik the transistor out and stick another one in?
Yeah, you could go ahead and try that, because you may have blown that one.
Some people on Skype.
All right.
Okay, so I yanked that one out.
So check this out. This is the newer panel. Far more brighter. Far more bright. More brighter is not
Not
proper.
good. Not properest English.
Not properest English. So this is check this out.
Okay, so I put a new transistor in there. And I'm turning it to the left. And it's stable. No, it's not. It's all over the place. Oh, no, it is more stable. No, it isn't. It keeps going back to 0.1, man.
Is it alternating current for sure, or is it DC? Now check DC. Press the select button.
Yeah. It says 60.
60 volts.
60 dBm.
So now tune it.
Going down, and now it goes 60. Turn it to the left, and it wobbles, and then it goes 60.
And that's all the way to the right?
All the way to the right. 60. Turn it a bit to the left. 60. Okay, should we just, like my grandmother said in World War II, check all external connections. I'll run you through what's connected here, okay?
Yes.
Okay, so we got coming out of the wall from a 12 volt, 800 milliamp funny little thing, like white thing, comes out and goes in through 2 crocodile clips to down here. Positive is coming onto this rail. As far as I know, it's positive. I tested it. And this one is coming into the bottom left of the coil of the green, which is on the outside. Yeah?
No, so the bottom left, no. That green one that you just touched right there should be going to the middle.
There is no middle. What do you mean the middle?
So the junction, so where you have the top left and the top right.
Yeah.
So you take the top right, you connect it to the bottom left, and right there where you're connecting those 2 wires,
Yeah.
that's where you're connecting that green one.
That's where it is connected.
Okay, so that's perfect then.
Okay, so check it. This is coming along the top rail, positive, coming to the bottom left. The bottom left is also connected to top right.
Okay, perfect.
Okay, and then this transistor's in the middle. I'm going to get rid of this so-called load of lights because they're not doing anything. Then I got a bridge from the rightmost thing on the transistor coming down to the negative output. And that's where the negative output is plugged in. And there's this green one here, which is the output from the coil, I guess. And where does that go? That's supposed to just be open. It's got a meter on it for the time being. I'll leave it.
Yes, you can leave the meter on it. That's perfect. Now that you took out the load, you can turn it on and check the voltage. And maybe the voltage may have changed because you changed the load.
Okay.
So the oscillation is always load dependent.
Okay. So yeah, now we've got 13.62 volts.
Yes.
Okay, well done.
Success.
Okay, cool. So now I'm going to start twisting to the left. 13.9, 14, 15.
Now
16.
don't go all the way over.
Okay. How far can we go? It's starting to sing.
It's okay.
Oh, it's starting to sing.
It's working, brother. You got it. You're oscillating the coil, sir. So good stuff.
It's working.
Nice. So now when you get your neon bulbs or your LED panel, you just plug into the output there, and yeah, you're gonna see some stuff working.
Okay, thank you. Now, is it possible? Where do I measure amps again? I didn't quite understand that bit.
So amps, check this out.
I
Let me
can't
just,
use this same bit for amps. That will short the circuit if I do, will it?
Yeah, watch this. This is how you conventionally measure amperage. You go. So I'm just gonna dial this down. I'm removing the positive, right?
Yeah.
So I'm leaving the positive right there. I'm getting my other meter. This meter is set to amperage.
Okay.
So I'm gonna put it on amps. The red
Just like this
probe.
one.
The red probe is gonna go directly to the battery, or directly to the input source,
Yeah.
right? And then the black probe is going to where your positive rail is on your proto board.
Okay, great.
Right? So then now when we turn this on, or start oscillating this circuit, we should see the amperage. Let's see if you could get a look. I want you to please note this, because it's important, because it'll minimize how many components you fry.
Well, I'm recording all of our conversations.
You see 64 milliamps?
Yeah.
And you see the intensity of the bulb? I'm going to tune this until it gets very bright. And then right where there's a drop, I'm going to back it up a little bit. And you see how I'm consuming somewhere around 200 milliamps?
Yep.
I want to bring that down to somewhere in a comfortable range of like 100 or so.
Okay.
Why? Because that means that we're only consuming, on a 12-volt battery, we're consuming around 2 watts of power, which is not bad at all for the amount of light that we're seeing here. Right?
Okay.
So then we can also go ahead later on, when it gets a little bit more detailed, you make these LED panels. Now watch this panel. We're going to plug in this panel directly in parallel with this other one. And it's going to be able to light both of them using the same power. So I'm just going to show you that real quick. Because this is something that we just discovered last night. And it's pretty huge in terms of lighting. Thank you. I've got... It's gifted my coffee.
So what is it that's singing in the coil?
It's an oscillation. It's the natural oscillation of the resonance in the coil. So you're creating a vibration in it. So I'm just plugging this in right here. This is okay. There we go. Voila, we have 2 panels.
That's insane.
Dude, it's the same current. Can you see that?
And that wouldn't normally light even one panel.
Not even one, and it's the same current. We're using 2 watts of power to light 384 LEDs. 384 LEDs for 2 watts of power. This is why I don't sleep. Because it was like, oh my God, 384. Can you imagine how many villages you can light? And this is like, and literally what I'm saying right now is, I may be able to construct another panel and plug in one more even in parallel, and it may be able to sustain that oscillation. So you can basically continue lighting rooms of your house using one tiny little 12-volt battery. 2 watts will light an entire house.
So how long will that battery last?
This at 2. So basically, what we do is we look at so this is 5 amp hour. So if you go to I can tell you for certain right now. There's a battery life calculator. So here we go. There's one that says per Kurt number battery life calculator. It's a great website. So you can put in 5 amp hour at discharge rate 0.100 milliamps. We calculated. That means that this battery will sustain this oscillation for 50 hours and only discharge to 80%. 50 hours, Brother Charles. 50. That means that you can take the tiniest of solar cells and replenish this battery and light your house for nothing. That's pretty much what we're showing here.
Okay. Okay, good. Well done, bro.
Yeah, man. So you have this website. It shows you manufacturer's 80% discharge time. So a manufacturer would normally tell you, listen, don't discharge this battery any more than this amount, or else your cells will start to deplete. So that's the preferred manufacturer's suggestion. So even at 75% discharge, we're still at 47 hours of runtime. So yeah, that's like, you know, and then what we're basically showing here is that we don't know if this is the end of it. We could just be getting into the very beginning of seeing how much intensity these type of systems offer.
Yeah.
So let me show you just from a distance.
It's pretty bright, bro. It's really, really bright. It's really, really bright.
No, that's it. I mean, 2 watts is never in history has 2 watts been able to light this many LEDs or this intense of light. We're basically putting out something like, at least 40 or 50 watts worth of light.
I want to get Marko. Can I quickly go grab Marko?
Oh, for sure.
Okay, one sec. And George. George? What's that noise, bro? Marko's just started a phone call with someone. He'll come in a bit.
All right, no worries.
Could you talk me through how to do the amp measurement again, please? I take it from the negative main input into the circuit.
The amperage measurement, you're gonna take that red pin on your meter.
Yeah.
You're gonna make sure that it's on the amperage measurement.
Yeah.
Unfused.
Amps.
Yeah, unfused. There you go.
Fused. It says fused.
Unfused should be far left, I believe.
Far left is 10 amp max fused.
All right, so I guess it's just you don't have an option for unfused.
Okay, well look, this one is like a really big one. I can use my smaller one, like yours.
Okay. Yeah, you could use that bigger one to measure voltage.
Okay, and wait, the smaller one, I'll just let go of these. And okay, for amp measurements, I'm on my amps here, milliamps, and it's on the right. It doesn't say anything about fused. On the left, it says unfused, 10 amps max.
Okay, that's it.
And then I hook it up where?
And then you're just gonna go ahead and hook that up so that the red probe is gonna go to the positive of whatever your source is.
Really, right down to the actual plug socket source almost.
Yeah, right onto the plug socket source, and then your black probe on your meter is then going to replace that alligator clip where it was before.
What alligator clip?
Onto your positive rail.
Huh, I just placed my red one onto the positive.
Yeah, so you put the red probe onto the source, positive.
Yeah.
And the electricity is flowing through your meter so that your negative probe on your amp meter is now positive still. So you have to connect that to the circuit.
Okay, to the next bit of the circuit. Okay.
Yeah.
So I get rid of my positive connection to the circuit from the wall, and I connect my negative to it.
Yeah. So it's a means of checking how much current is flowing through that positive rail.
Okay. So here I got 0.97.
0.97, and that's pretty much, I would say that 0.97 should be halfway, right? So you should be able to turn your potentiometer more to the right.
Yeah, I turn it all the way and it goes down to 0.12.
Yes. You're working, bro. You got it.
Okay, cool. And then I got I turn it to the left like halfway, and we can go like when it starts singing it. Okay, it's like this. Nice tune. A little bit squeakier. Okay, so we're at 0.63. Now, how do I measure the amps coming out?
0.63? No, you don't want to go that high in amperage. Make sure that it stays below 200 milliamps.
Oh, okay, yeah, sorry, 0.063.
0.063, okay. Yeah, never go up that high because then you'll fry that transistor. Those transistors are delicate.
Okay. You have to be careful, huh?
Yeah, so what some people do is they put a resistor before the potentiometer.
That's what
and
you
that's
had there.
it.
Oh, it's so clever. It's so clever.
Yeah. So yeah, you could go ahead and you can get a certain value resistor, and I think it's like, you can get like a 1K resistor, and just put it right there in line so that when you turn it, you don't have to worry that your circuit is gonna pop.
Okay, cool, man.
Okay, cool. It's just a little protector. Yeah.
Okay, so how do I measure the amps that are coming out of the coil?
So that's the same thing like before. You would go to the collector pin.
What's the collector pin?
The collector pin, so the middle pin on the transistor.
Okay. Yeah.
So basically, your transistor has 3 pins, right? You have your base, your collector, and your emitter.
Okay.
And basically, the base is like the volume control for your dimmer on your lights in the house. You have your little switch. The base is what turns the transistor on and off. So what you're doing is you're putting a potentiometer here through the coil, and it's creating its own oscillation with the coil, and it's vibrating it to turn on that transistor through the base. And then it sends electricity from the collector to the emitter. So it's like positive flows through the coil and then goes into the negative. So it's basically like you're regulating a light switch almost.
Okay.
It's it, yeah.
I can't.
It'll start to.
I heard what you said. I heard what you said.
It gets easier over time, man.
Sure.
I remember in the beginning, man, it was just like, oh, how to learn about these transistors and collectors and and then you realize it's the same circuit for everything. And it's just like, okay.
Yeah. Okay.
Yeah, it's really not that complex.
So wait, it goes in through 2 points though. It goes in through the base and through the second one.
Yeah.
What's that about? What's going actually on physically inside of that?
So what's happening is you're sending a positive voltage into the center point, right? So you have the coil, you have that little junction where you tie the two vortexes together. So now you're imagining if you have a positive voltage going in there, you have positive coming out in both directions of the coil, right? So then this one is going to your collector on your transistor, and then this one's going to your base. So then through the potentiometer, you can create a natural resonance in the coil by tuning it in that way. So it's the same principles of a joule peak circuit. So that's how it ends up working that way.
Okay, cool. I think there's aliens listening in on the line, bro.
I thought so too. That sounded kind of strange.
How's it, my bro? How you doing back there, kids? How's it from Malibu? We got it all working. Yeah, it is cool. How you doing, man? Hi, little man. How you doing? You cool? Yeah, good. You're looking very good, man. You're looking good.
What are you getting, bags for your mom?
Hey, cool. Hey, see you later. Okay, so how do I measure the amps on the way out, bro?
And so the amps on the way out, you're basically going to do the same thing. You're going to take the collector. Marko!
Okay, here's Marko. Here's Marko.
What'd you see? The baggy pants and no?
How's it going, Marko?
Feeling older. I'm okay.
Feeling older and looking younger.
You would try and fool me, huh? I went running at the beach today.
Nice.
Jumped in the water and it felt great. So things are fine. You know.
Good stuff. Charles got that. He's got the circuit running there.
Yeah, I'm just trying to remember. Here we go. No, that's why not. That's why not.
Why not?
I knew it was going to be a very, very in-depth process.
Yeah. Check this out. This is the latest from last night.
Yeah, can you hear it?
We've got 384 LEDs oscillating now.
That's beautiful.
Thank you. On one tiny little 12-volt battery, using the same circuit that Charles is working on there. Yeah. And this is only consuming somewhere around 2 watts of power. Wow. And 2 watts of power is putting out somewhere around 60 to 70 lumens worth of light intensity.
Yeah.
No sleep last night.
You shouldn't do that. I got up last night and I was reading the Baha'i scriptures. Got up and read for hours. And it sure hurts, you know. You think you got it in you to stay up, and then it just hit me. You know, Charles says that he has people that will underwrite things. And obviously, Charles is here to help. He's not competing with me or you or anybody. And then I keep on being in business meetings. You heard, and then I've had Tyler, I had Jeff with me in some of those meetings. I've had Randy with them. You know, I try not to micromanage everybody. So everybody exchanges phone numbers and this and that. One of the people here, where I'm at, has offered to underwrite the project. George just wants to show him the hardware, and that's one of the things he wants to do with Charles. I call it the Nunez coil, because
it's a unification coil. It's we're unifying the principles over here. Nobody's gonna like Nunez coil.
I think you're wrong. And then someday it's going to be the Nunez Classic coil and the new Nunez coil. You can see.
We'll try to shorten it down to U coil, if anything.
So many people have so many different types of coils, and they energize them differently, that it's easier to put a person's last name on it just to keep an index, a reference. You saw Jamie selling his winding machine.
I did. I saw it's 20,000 or something.
Yeah, more than that.
30.
25.
That's pretty robust. Now, is that an automated system, or is it a type of manual feed type of thing?
I think it's automated.
Automated.
You know, the hardware can be expensive, so I haven't even evaluated what's in the right ballpark for the price of that. I know he had hired a programmer, and it took a lot of hammering out to program to get it right to do the Rodin coil. You know, I don't have much say in it. I'm not really involved in any of it per se. You know, I made a plea for funding for Jamie, and then a man named Dean funded him when we were Tesla techs. But anyway, and then so I haven't received any funding. I still don't have funding. I'm still underwriting myself. I'm paying everything out of my own pocket still right now.
So Jamie says that he's trying to sell that system. Is he not doing his business anymore?
Well, on a cursory guess, I think he maybe got burned out. You know, he's certainly very talented. You know, he pioneered a lot of the different aspects of a lot of the discoveries. I have a saying about Jamie. My saying is that whatever he touches turns to gold. I say he has golden hands because, you know, he finds hidden in the frequencies and in the coils those abilities. I think when you eat T-bone steak every night, when you have money too, and you have all the food you want, and you get comfortable. With the money, he bought a big square place, like, I don't know, 12,000 square feet or something. You know, he rented out part of it. He's got an income. You know, he can do whatever he wants, or not do whatever he wants right now. So
It's a nice position to be in,
yeah.
except for the T-bone steak part. We're vegan, so we don't partake in that. But sounds like a nice position to be in.
Some people never break free, if that makes any sense. Some
That's
people,
true.
yeah. A woman once used the term how she had a catastrophe in her life, and that had allowed her to embark on her spiritual growth. And her way for referring to it was, as she said, she got slammed by God.
That's
So,
right.
you know, it's how we deal with our problems. You know, if we use them as leverage to grow, to catapult ourselves forward.
Yeah, use them as the drive and the fuel.
Yeah.
That's right.
But some people, you know, poison is their medicine, you know. So,
I like to leave that stuff alone.
you know, you're in a position like I am now. You get a lot of correspondences, a lot of emails, a lot of phone calls. And I directly tie the level of anger to how much cigarettes and coffee and alcohol and weed and how much more, though, so harder drugs. But it's amazing how it skews people's thinkings. And but you can always, I always look through any correspondence I get straight to where the source is, which is being under the influence of something. So anyway, I haven't talked to Jamie. I tend to be very aloof, not with everybody, but with Jamie, you know, I'm close, I'm personal, but he kind of, in my view, he's an independent. He has to stand on his own feet, and so I've been not maintaining communication. He's done a lot of good things for me. He's done a lot of favors. He credits himself with putting up some of the first Rodin coils ever up online, at least on YouTube, to create the. He believes he created the momentum.
He did, I feel.
I think that could be true. Yeah, I don't know, but it could be true.
I learned a lot from Jamie in the beginning of, you know, how to wind the coil. He had a whole series of videos up in the beginning where he took the regular rocker toy, you know, this type of setup, you know, except this one we wound into an Abha design. But yeah, I remember when he was showing people how to do that, and he showed energy reduction effects, and he demonstrated the monopole anomaly and those things.
Yeah. Actually, Tyler and I did that monopole thing first.
Okay.
But he followed up with that. He should have cited or referenced it. He didn't. But that's par for the course.
Well, not to mention the videos are down now anyway.
His first round of funding, the terms where he had to take them all down, and he wanted the money, so he did. It's a real big problem for all of us all the time.
Yeah. Well, I'll make sure that I'll keep my my most important videos up. I did filter out some of the more confusing things. I think that a lot of the learning process, you know, has kind of narrowed out our most important effects at this point. So to have people looking at the old videos is kind of like counterintuitive to what needs to be presented at the moment.
Well, refining or culling things is normal. Outright removing everything is something else.
Yeah, yeah. And that's not what I'm interested in doing either. I think that it's important to allow people to have access to the information. So yeah, I left up that how-to video. We've got circuits posted online so people can go and find out how to wire it up, and at least the very basic the first step is there for people. And I'm gonna make sure that that stays there. So that if anybody wanted to take the idea and implement it a little further or expand on the concept, that they have that ability. Because I think that was a crucial part of our learning process. Being able to see those videos online and follow up Jamie's work. Are you guys getting? What are you guys getting?
You're at a train station?
Oh, that's a train station.
No, it was coming from you.
Is that a UFO? What is that, guys? But yeah, I feel that it's very important to keep that line of information open for people. So whether or not we just go ahead and route that to a different type of web-based platform or something, a little bit more open source or a database type of setup. Either way, I'm gonna make sure that we allow people to replicate
It's a real
at least
problem.
these very first steps.
Well, I mean, if I get some funding guys, they want to talk at 10 o'clock for like the two different teams that are here. I wanted to show you the plans, but Franklin designs power stations. He's like part of the Children of the Law of One.
I won't be in. Are you referring to the Skype conference?
Yeah.
I don't have the patience.
Okay, fair enough.
I can talk to somebody privately, but I won't get in with the group. It'll eat up too much of my time.
Okay.
And it'll fatigue me too much.
Okay, that's fair enough. Which is this? This is the output. But these guys are basically just keen to get this technology out there. They don't want anything in return. It's like a philanthropic giving. So we just need to show that we can deliver and do what we say that we do, and then achieve goals that get this out there. So that's the structure. So we don't need to, keep these things online. It's a very, I don't know if it's an American thing, but like, it seems that energy over here is really intense, like this profit at any cost, like it's mine kind of energy. I don't know.
I it's in the UK too.
It's in the UK too, but like, I don't understand why people over here are not just like, oh no, we're not doing it like that. We're doing it open source.
Well, you happen to be though in Los Angeles. Los Angeles is a little different than other places.
Okay.
This is a dog eat dog area.
Yeah.
So Marko, what exactly would be your ideal type of outcome for all of this? Like, what would you like to see happen in a detailed type of in an ideal world?
It's all going right past me. It's all passing me by. Nobody understands the math. Charles is incomprehensive of it. He doesn't know where this came from or what's going on. I haven't explained it to him.
I've watched some of your videos. I've been studying some Schauberger. And I understand the kind of philosophical bit behind it.
Nobody has a reference, a bearing. So I'm planning on going and getting a tent and living out at the beach, to tell you the truth.
That's a good plan.
There we go.
I understand something.
I've been giving several classes a day. I just was approved by the Point Dume Elementary, Marine Science Elementary, which is a top school in Southern California, maybe the top 5 elementary school, to teach the children the enrichment program, but nobody's funding me to do it. Nobody's giving me any money. Nobody's staking me. You don't know what's been going on with me, Daniel, but I was on 16 planes in the last 2 months, and I'm very, very tired. I'm very burnt out. On top of it, I've been meeting with people about. I just moved. I moved here to Malibu. I give myself roughly. Everyone says 90 days, but I don't know if I have staying power to make it past November. I've been here already for a while. These are my good friends. They're my extended family, where I'm staying at. I've known them for many years, but I feel like I'm totally dead in the water. I'm not focusing on what I want to do. I'm not working on what I want to do. I see a lot of problems in your design, in Randy's design, in my design. and I want to address them with all of us together and enhance it. George, this is Daniel. Daniel, this is
Hi,
George.
Daniel.
Hello, George.
Daniel and Erica are the inventors of the Nunez coil. There he goes. One of the I can't touch the coil because it has leads on it now, and he's energizing it. But you know, Daniel, nobody's ever done a second layer knowing what they're doing. It's all done by free streaming, improvisation. You know what I'm saying?
Sure.
And the whole notion of a counterwound crosshatch in the math, when you have a toroid, I take the parabola, which is the upper side with the underside, and because it's following a log, I'm able to superimpose them and put numbers into the tiles and have an expansion and contraction that's following a log. You still with me? But in reality, there's no crosshatch. It's all a straight flowing. Are you still with me?
Yeah.
Okay. Are you interested
So
in
that means that you would think that it would be only one directional, clockwise or counterclockwise.
You're interested in all this? Because I'll continue.
I've got
Of
it
course.
recording.
Well, that's fine. You can record mine from now on too. You'll show me how you do that.
Okay, cool.
There was a movie once, a long time ago, and Charlie reminds me of the character in the movie. It was a good movie. I can say that I know the British because I lived in Gatwick Airport for over a week on the floor, camping out, waiting for an airplane during a bank holiday.
Nice.
It's an amazing place because I've never seen anybody maximize so much space so efficiently.
They're good, aren't they?
Yeah. Okay. So,
What was the movie?
I was saving that. It's wondering, isn't it? I'll have to find it. We'll have to find it together.
Cool. Listen.
He's turning the corner.
So you were saying
What have I done now?
about them being only one direction.
The next thing is I don't do stranded wire. Don't believe in it. Everybody uses stranded wire. We know that there's advantages. There's more surface area. We know that it's also more flexible. Right? But it's as things get better, it's going to fall by the wayside, I'm sure. You still with me?
Now, what about so the only reason why we even considered using stranded wire is to prevent that skin effect. So what happens is when you start to get into that resonant spike zone, you get a lot of breaching if you don't have stranded wire. You get ozone production, and basically the coils rip themselves apart. So maybe that's due to the conductors that we use. Maybe it's like copper is not the right one.
I'd be interested in addressing that because when you don't do them with the crosshatch or in different ways, that was the one distinguishing feature of a Rodin coil when it was first tested. Now, you know a Rodin coil, which I call the flux thruster, right, atom pulsar, has never been even right? So you got to start somewhere, you got to dig in wherever you're at, right? Hi, Cloud, how are you? So, was that they didn't have that resonant problem. Was that it had a much greater frequency and range than a conventional winding coil. Probably because of the fact that it's a Chinese finger pull, because it folds in on itself. You know what I'm referring to, how it's made.
Sure.
You know, anyway, I didn't mean to go into too many things. But
That's good. That's good. Did we figure out how
I'm following, Marko.
Did we ask him?
Yeah.
George is talking. I'm sorry.
Too much impedance?
So George, do you want to explain to Daniel? Could you come on over here for a sec?
Check out what
It's
he's
my
done.
pleasure.
Okay.
Come sit down.
You're going to pull up a chair too.
No, I'm not going to pull up a chair.
There you go.
It's like a nice, comfortable spot there.
If you pick up the camera, you look out, you'll see we're overlooking the ocean.
I'm showing him earlier.
Charlie showed me earlier. Yeah, beautiful, absolutely amazing.
George, you want to come
I'm gonna
sit
make Marco's chair
That's
more comfortable.
that's Zen.
I prefer to stand. What is it that you would like me to do?
Okay, so I guess what you're saying, George, if I'm repeating it right, is that upon demonstration of this coil, showing greater output than input one way or another, one amount or another, that there should be unlimited funding for whatever everybody wants to do. Is that an exaggeration?
That's my plan, yes.
So that's the,
But I don't know about unlimited funding for what everybody wants to do, because I don't have a plan from anybody what they want to do yet.
I got a good plan.
So, but yes, what Marko is saying is, if I can show myself here what you show in your video, I've funded 300 companies, taken 40 companies public, hundreds and hundreds of millions of dollars, billion-dollar companies. There are 10,000 people working for billionaires trying to find a better place to put their money. Right there where you are in New York, the buildings are tall, and there's thousands and thousands of people in those buildings looking for investments for their bosses, for their investors. And we have access to them all, and they're waiting every day for me.
I guess that's what I wanted you to say. Thank you.
It's
So,
absolutely amazing.
You know, it's like a bar. You got all these beautiful single girls standing at the bar, and then you got all these guys wanting to talk to them, but you need somebody to break the ice. I'm the ice
Isn't
breaker.
that the truth?
I'm the one that matches them up.
Can I just make...
The banks are full of money. There's literally trillions of dollars looking for something to do better than what it's doing.
Can I ask a
That's
question?
true.
Sure.
I was just watching, what was it, the rebirth of the electric car. I was looking into some of that stuff and seeing how much chaos they're going into right now because of the batteries, the battery cells, and how expensive the battery cells are, and then they can't get voltage out of things, and just some range extension on some of those EV cars will bring down the price of those cars significantly.
Is one of those coils to your right one of the coils you're making for Marko and I right now?
Yes, so we went ahead and finished up 2 of them last night.
That's 2 watts powering all those lights. 300 and something.
Oh, wow.
So
There's never had 2 watts.
384 LEDs, and that's only powered by that little 5 amp hour battery. And the amperage that we're using is somewhere around 100, so less than 100 milliamps.
Mm-hmm. So what we're getting is a whole kit from you to do that?
Yes.
Or we're just getting the coil? Okay.
So if you guys wanted me to build the circuit, I could definitely go ahead and box up a little circuit. And,
Yeah,
this is a demo of the circuit that we made. This is exactly what you have there, Charles, just boxed up and soldered into a box.
Well done.
So it'll perform the same function, and it doesn't necessarily need the dimmer either. We could just go ahead and put a resistor instead, so that it ends up just being a little on and off switch, and that's it. Just plug and play.
It's cool to make it tweak, though, man. Can you hear
Yeah,
it?
yeah. And it also allows you some flexibility for different loads.
Yeah, I don't care anything about speakers, about sound, about magnetic fields. All I'm interested is input in, input out. That's all I care about.
And what we're looking at right now is probably 60 watt worth equivalent of light at 2 watts of power. And right now what I'm suspecting is that we can get another panel on there as well. Mm-hmm. So we could possibly light over 400, almost 500 LEDs.
Mm-hmm. Yeah. Guys, can I ask a quick question of everyone? That if the financiers, Laurie, if the financiers of whatever plans you guys make are coming from that commercial world, those big buildings, then they have like an obligation to make this into a normal investment.
Of course they do.
But if we do it in a process which is non-for-profit, where things are donations from philanthropists with a lot of money to give, to get this
You can do that. You can do that also.
at the same time.
Sure.
Okay.
I mean, we're taking it to Bill and Linda Gates also,
Okay. Cool.
and David Lynch Foundation. So we're taking it to nonprofits also.
Okay. And then how does it work as an intellectual property from an investment standpoint? Because
Well, I don't know that there's any intellectual property here. What there is competition.
okay, so if you build a factory that's producing Rodin coils and selling them, then that'll be good. And with open source instructions, I mean, the idea in our plans is that anyone would be able to take those instructions and build their own plant and start building their own exact similar versions.
Hopefully, every public school in the world will be teaching people to make it.
Okay, cool. All right. Well,
But even with people making them, they're just, this is one thing, but there's 1,000, if not 10,000 different uses. And so even if you open source it, you're going to have niche companies in Angola making, automatic goat milking machines that, that ride around on the goat and milk them on a timer without any electricity or hydraulics. I mean, there's 1,000. I'm just giving that as an example.
Okay, I see.
But so the idea of trying to protect, or that there's not going to be enough to go around is you couldn't build enough factories for 10 years to make these 24/7 for the uses.
And just when I was talking to the lawyers, they were like, "Have you got?" Of course, we're trying to make it open source.
Daniel, I'm interrupting. This is Lori. Lori, this
You guys
is
have-
Oh. Is that better?
Hi, how are
Hello.
Lori wants to see how many lights you're lighting on 2 watts.
Can you show us the lights again?
To make Lori happy.
It'll at least make Marko happy, thinking that Lori might be happy.
Lori, how much did you pay for electric last summer or last month?
Okay,
Last month,
so-
$833.
$833.
This is the little battery running that light.
How long did they say it could last? For like 5
It's like
days.
50 hours.
Okay.
50 hours, that means with one tiny little solar cell or a tiny little wind generator, you can replenish that run battery and sustain the oscillation. Not to mention, we have an idea now that we could take the same frame and basically just dig a hole in the dirt and bury a coil in there, and that can also operate as the battery. So that's going to be pretty interesting when we actually get to doing that.
What's the smallest coil you can make me showing the same thing, showing even 50% efficiency?
50%, 50% of this, I mean, we can shrink down the size. I mean, right now what we have is pretty stock at this point. We have all the CAD already written up for these size frames. And we want to pretty much just keep it at that same size for right now. And when
what you're doing, the way you're winding these, is with a CAD machine?
Well, what we did was we wrote up the CAD frame, and now we can ship that out to. We can basically send it over to different manufacturers to source materials for that. But it's already stocked, so it's set that the frame is going to be this size.
Okay.
So we're using 4-inch discs on there.
I got it.
Yeah. So what we could do is we can make them with heavier gauge wires. So this is another coil right there. Can you see that?
Yeah.
So that has 6 layers on it, as opposed to this one that's running the oscillation with only 2 layers.
Mm-hmm.
So that means that when we have 6 layers, we operate the same resonant frequency at less consumption. So instead of it being 2 watts, we'll run those lights on 1 watt, because we have more copper on there and it resonates more.
Great.
Well done.
Thank you. It's pretty scalable. The short answer is it's scalable. We could design the frame. Excuse me. We could design the frames bigger or smaller, but we need to write the software so that we can get the parts made precisely.
I got it. Very good. Thank you.
No problem.
So Daniel, because everybody's also looking at corporations that are licensing and this and that, have you considered doing any provisional patents or anything?
Actually, what I did was I looked into the patent information, and if the frame has been out for over a year, I don't even think it can be patented at this point because the frame has been out.
Right.
So for this particular item, it's perfect for open source because nobody can patent this frame. Now, moving forward, if we were going to get into some kind of licensing agreements, then we can make a particular application, customize it to that specification for whatever it is that we're making, and then we can go ahead and proceed with the patent on that one thing in order to pique interest of those people who want to have exclusivity. But, we can actually go both routes simultaneously, do the open source and cater to the people who want
Sometimes they
to
call things, Daniel, they call it a loss leader. So that's your loss leader.
What's that?
It's called a loss leader. It's like when you go to the restaurant and you have a mint, on the table, by the maitre d'. Or like you go to C's Candies, and they give you a free lollipop.
Yeah.
Or any candy sample. It's your loss leader. Does that make sense?
Oh, that's the frame right now.
Yeah, it's your loss.
Okay.
Yeah.
And you know what? For me, the loss leader works. I think that it gives people enough information and enough tangible stuff to work with, so that they can familiarize themselves with some of these concepts, and then after that, they can take it with however it is that they want to apply it. But I think that it's like kind of like an aquaponics system. If you teach somebody how to make an aquaponics setup, they have their fish, the hydroponics setup, and they can grow their own food. Now, you don't have to get into detail on everything that you put in as a bell and whistle for your aquaponics setup, but at least you have the people who can feed themselves and create an infrastructure that's sustainable. So I think that for what we're giving out now, that's perfect for the people, and with minimal copper, they can go ahead and run their lights. So nobody needs to be in darkness anymore.
Bro, you got to check out my friend's Seaponics kit. He does it with seawater and grows vegetables and stuff in seawater, and they grow like nothing else. It's supposed to be impossible, but it's deep. It's good.
I believe it. Yeah. And wait till we get some coils pulsing.
Yeah, Seaponics. No, it's just like he does it at home. He's got a home like nutraceutical company, and he grows all the stuff in his garden. His 5-year-old daughter has a natural range of healing products. Like they're all just like.
I'm gonna have to look at this.
He's cool.
That's pretty amazing, man.
Yeah, he does water. He restructures water in South Africa. He used to develop viruses and stuff for the South African government and beat beatniks to death basically, and then he had a big enlightenment and swapped sides.
Check this out. I just wanted to. So we went ahead and got a little creative over here with this unification coil, and we went ahead and we were trying some stuff with structuring to see if it would taste different. So I was basically sucking water through this coil.
Right.
So I put the hose, to run through in parallel with the Rodin coil overlay on there.
Nice.
Yeah, so I had the water in there. I was pulsing the 144 and just sucking the water through and tasting.
Everybody can be sucking and drinking on it while watching TV.
Amen. There we go. It's drinking from the fountain of youth. That's it. It's like, one step at a time. But if a pulse magnetic field is supposed to structure water, there's no reason why we can't just drink right out of the coil. You know, or do something what your friend is doing with that system, and just filter the water through multiple times through the vortex, and it's gonna attain some structure.
Yeah, it will. But the best way is to allow water to flow through flow forms that induce the vortex. That water will naturally fall in a vortex. Yeah, H2O or like.
Don't underestimate, Charlie, the potential of imprinting water and the different ways of doing it. The industry's in its infancy.
Yeah, there's a company in Germany that's frequency in water and turning it into cleaning products. It doesn't change from being water, but it's able to dissolve things that it was never and clean, like astringent cleaning product, just by changing the frequency of water. People have been sending me this stuff. It's like,
I believe that's true.
Yeah.
That's interesting too. I'd love to see that.
Yeah, I got the patents here. It's far out.
That's all right.
Hey, so I'm going to show everyone my plans and see if they can help me, or if they can just tell me to be quiet and go like, no, be still, be quiet, meditate. Yeah.
I'm sure it'll all work out.
Yeah, I know that much.
And moving forward, you know, you guys have us working over here, so.
I'm having a very hard time. I'm really struggling.
What would help? What would?
Well, I wasn't discussing just how impoverished I am. I'm discussing other things. What I'm struggling with is that my desire was to see everybody wants shares or to invest. It's a real problem.
We want to donate.
But see, George doesn't believe that is the way to solve the problem. It's an adjunct. It's a part of it, but it's not the main. Now, I'm 57 years old. I started this when I was 17. And I can name under 5 people who've given me over $1,000. Okay, so donating doesn't necessarily work that easy. I wish it did. I wish I could say, George, you know, you don't have to appeal to these people's greed. That you don't have to be creating shares for people as an investment where they can get a return. I was trying to do, where the principals involved, like me or whoever else, got a flat salary, didn't even have shares. I didn't even want shares. Nobody takes me seriously.
Look, these guys take you seriously. They build power stations, and they build the O2 data networks and the largest data networks for the biggest mobile phone companies. And Daniel, I'm going to share my screen with you. View, edit, share. Where's the word share? Conversation, share screen. Okay, start. Okay, so this is just the criterion for the board is people are vegan, 5 precepts within one's own life by application and by voting, and this is just for donating, and it's basically this. Daniel and myself are the only, and his wife are the only people I know with the credentials to get on there right now, but maybe it will change. But anyhow, beneficiaries are discretionary. This was the original structure founding. I'm setting this up, and it's the 5 Buddhist precepts for harmlessness. Refraining from speaking what isn't true, stealing, killing, sexual misconduct or intoxication. Those are just principles for harmlessness. That's the constitution of this organization, and it creates projects. The projects are...
Go back. That's right there. I mean, unfortunately, in the UK and the United States, everybody drinks alcohol.
Not everyone.
I don't drink alcohol.
Yeah.
Okay. But I can definitely say that when I put an ad in the paper for an employee, for instance, and I say no drugs, I can definitely tell you I don't get one call.
Yeah, but the thing is that it's like while they're at the workplace, as an individual, they're free to do whatever they want. But as an organization, we can never be refining alcohol. You know, you can set up another organization as an individual and do that, but this organization will never be like purifying and giving, potentizing alcohol or whatever.
Okay, continue sharing with me. I see you're sharing.
Okay. So the first group 1, is working on the neutron accumulator. Group 2 is working on the Abha coil. So then we get down to 3 different tracks. Group 1 is to
Who
create.
helped you write all that? Someone helped you. Did Tyler help you with that?
No,
Who helped
Franklin. Franklin, he builds power stations.
That's just you and Franklin, no one else?
And a few other guys. Here's the team in the long run. Is a business operation manager. It's a ridiculous title for me, but that's like because I'm registering it all as what it is. But technical project manager is a guy called Lorenzo. Lorenzo designs the O2 mobile phone networks for the UK. He's just redesigning the global Vodacom network. He builds and project manages big electrical engineering projects. Franklin designs power stations and builds power stations. He's working on the Neutron accumulator, which was Nikola Tesla's student's device. He's got that working up in San Francisco. On Sunday, I'm heading to see him and taking this to a particle beam physicist called Kirkwood Ruff that works with NASA, and he's going to run a full spectrum analysis on it. He writes reports so we're going to come up with a report like this for the Abha coil. Come on. Okay, so he does all of his testing. He writes reports for like this introduction about what's going on here, what's happening inside the accumulator, what goes into it, what's the test procedure. This is all like at the highest level. All the equations. He's so thorough. He's a children of the law of one. It's all about harmlessness, just like us. So he also qualifies for this board, and so this is with audio stimulation. Basically all the things that go into it, all the things that came out of it. As you see, it's also just a desktop experiment. These things sit end to end. This is an elongated image by mistake, but it's supposed to be perfectly square on the side when it's a proper representation. And just like this, they get it into resonance by putting through the sacred geometries and through the core and through this thing, and it gives this feedback, just like we're seeing in this device, much more than you're putting in. Now he's recording this. Now these guys are putting 10 volts in and getting 3,000 to 4,000 volts out. So this is like 5,000 times over unity. And here's all explaining where the resonance is, and here's the equipment. It's all open source. So he's going to help us develop this.
Call me Charlie.
Hi,
Charlie, Big Paul.
Hi, how are you?
Your
Very,
fellow
very well. Lovely to
countryman.
meet you.
Oh, hey, Marko. How you doing?
Okay, babe.
Didn't recognize you without a shirt.
No, you'll never recognize me with that.
Okay, so this is it.
Paul, let's see Daniel for a second.
Can you see us? Yeah.
Hello.
Paul, tell Daniel what you do in the film industry. This is Daniel Nunez. Daniel, show him how many lights you're lighting up and how many watts per second.
Okay, sure. So we've got 384 LEDs,
Okay.
and we're using a 12 volt, 5 amp hour battery, and it's only consuming 94 milliamps.
What would
Sounds
those?
very impressive.
What would they normally consume?
Well, it wouldn't turn on this many LEDs. It'll
No.
turn on by itself 6 of them.
No, I mean if those were properly being, if you plug them in to what the power supply they required, what is the power consumption for that many LEDs?
For each LED, it should be around 20 milliamps.
Okay, and you've got how many running at what? Okay.
Well, the configuration will vary. It's basically it all depends on the setup that you would use. These panels would never run on 12 volts, and so there's no real way of me saying like the way that the panel's set up right now to operate on 12 volts, it would never happen.
Okay.
But
So
he's got 2 of them
And we have 2 of them, yeah.
because this amplifies what we put into it.
okay, okay, thank you. That's the bottom line.
Yeah.
So normally the way that it would work, you would have 6 of them in series.
Okay.
That's able to light with 12 volts. And then you can connect multiples of 6 in parallel. And that consumes more and more amperage. So ultimately, when you get into like having 2 rows or 3 rows, you're already well over 200 milliamps. So right now what we're doing is we're lighting 384 with 94 milliamps. So that means we're under No, let's just go ahead and get you a wattage reading here.
That's what I wanted to do a A/B. I want you to tell me what it should be and then what it is.
So we're running 1.12 watts right now. It's under 2 watts. A little over 1 watt of power is powering these lights that would never turn on unless you had, you know, a significant amount of wattage.
Tell me how many watts it would take to light those now. I need him to be able to. You said 1 watt versus how much? Or let's say 2 watts versus how much?
2 watts versus. You know, it's hard to say because these are custom panels.
Yeah.
But I could do that with regular Christmas light bulbs. And what we did do is each one of those Christmas lights that are regularly 3 watts of power, we can turn them on with around 2 watts. And then we can plug in more than one at the same time.
Why don't you set up a control experiment where you get one or both of those circuits running off a normal setup? So plugged into the wall off a transformer to get them to run at the same amount of lumens, and then measure the watts that's going in. Set up a control experiment, and then compare that to how.
Yeah, we have that video posted online on our YouTube channal.
Yeah.
We already did an apples to apples
But
test.
I need that. Which video is it? There's so many I get lost. So let's pull it up right now.
I narrowed it down so you won't have that difficulty anymore.
Well, but confirm me, please.
It is. Let me send you over the link.
I'm on your thing.
Vortex Technology side-by-side lighting comparison.
I got Rodin Earth Coil Magnetic Field.
There we go. Vortex side-by-side.
I can't see that one. I'm on uploads. There's only 3, 6, 9, 10, 11 here.
Yeah, Vortex Technology. It says side by. You're looking at it right above the levitation.
Oh, stupid me.
No, brother, it's.
Vortex Technology side by side. I just clicked it.
That's it.
Okay.
So that's using a conventional type setup where we're running one through the wattage of the wall. Let's use the ads.
Yeah. Capitalizing on your inventions.
Oh, you're trying to pay the phone bill for the month to receive calls.
Can you see us? What are you seeing? Are you seeing us or are you seeing the screen?
I'm seeing myself.
Okay, so
in delay.
You don't see us. Because
I see you guys a little tiny in the corner.
Do you?
Where are you based?
I'm in New York.
Oh, okay. Well, how long have you been working with Marko?
I've been following Marko's work for around 4 years now.
Okay.
So I first got interested into Jamie Buturf's discoveries with regular Rodin coils, and then we just started getting creative after listening to Randy revisit the math and his interpretation of it. And then started trying to figure out a way to replicate a workable unit that produced more output power than in. So it's been around 3 years that we've had actual implementation and R&D of working units.
Okay.
In total, around 4 years of the Vortex math, though.
Yeah, I'm not really an engineer or into the math. I mean, I'm just accepting that it all works, and from what I've seen on the YouTube videos, it does. I'm just wondering about all the applications, because to me, if it works, I mean, it's like even like with like electric cars nowadays, you'd probably be able to utilize it so that there's more charge or more something or another, right?
It's just
endless applications.
But just think of it like this: there's endless energy. You have free energy. So
free energy.
So endless amounts of energy that you can, just as the universe comes out endlessly.
That's fantastic.
So it's like, oh, we can let go of so
English?
much. Yeah.
Where are you from?
From London in the south.
Oh, okay.
Yeah. Charles is from New York.
Yeah, that's the thing. Whereabouts are you from?
From London Northwest.
Okay, lovely.
Tottenham supporter, I am.
Okay, lovely. Yeah, cool. Yeah, I don't know anything about football.
Oh, okay, yeah. Well, it's my only tie now. I've been here since '84.
Okay, cool.
Yeah.
What you doing out here?
Pretty well. I've been involved. I have a creative side and I have a business side. I've been involved in. I've created a couple of different publications that I've sold. I've just sold one called the Malibu Chronicle that I was doing for about 9 years. I'm in film, and I've raised money. And that's probably and I was working with George raising money before for something. So I've worked with people in the investment world for a long time. So I've got that sort of business side to me. Yeah, I mean I prefer the creative, obviously, because creative is creative. But I can smell money here, so it's really really interesting.
Well, really, it's the end of money, because all money is based on competition for the scarcity. But this is based on abundance, so this doesn't fit into our.
No, I've got that. I mean, I'm a totally God-conscious.
I know you are.
So I know
you are,
exactly.
but really, just to appreciate it, it really is.
Yeah, no.
It dissolves all our national barriers, all our economies that are based on war and scarcity.
I know. It's worse. It has to be. That's what part of the whole new consciousness, really.
Of compassion.
Yeah.
And love. Yeah,
that's true.
It's so exciting. So.
Can we set a time right? Can we set a time right now?
So,
can I grab that?
Yeah, go.
Tell me what time? 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock. 8 o'clock.
What can you?
Danny.
Yes.
Can you be awake at 11 o'clock tomorrow morning?
11 o'clock my time is 7.
No, you're in New York, right?
Yes, New York my time.
Yeah, New York, your time 11, 8 o'clock my time.
I'll be there.
Okay, I'm going to call you on Skype, and we're going to show one of my partners some stuff.
Sounds wonderful.
All right, we're on for 8 o'clock.
Yeah, I mean, I've got to sort of get myself up to speed as much as I can.
So I'm putting one of my billionaire investors on with us in the morning.
Good news.
That is absolutely wonderful news.
I'm trying to short circuit the circuit.
And that's impossible.
I like that.
That's
Okay,
right.
I'll put it a different way. I'm trying to rapidly amp up the coil.
That's right. Well, we've got. I just received a package of these high voltage thyristors. These are super high voltage transistors, Charles. So the same thing that you have there in that little circuit box.
Yeah.
But these handle a much higher voltage.
So where did you get those?
These are custom order. I got it from Jamie Co Electronics online. So these are going to push the coil to the limit, and we can really see how many thousands of volts we can push out before it fries itself.
What's their limit?
Right now we're getting these coils producing somewhere around 600 volts on a 12
No, what's the
volt
limit of the transistor?
These transistors, they go up to somewhere around 2,000 volts.
And what's the watt limit?
Wattage, I ordered some really robust ones, 150 watts, just crazy.
Just crazy.
Yeah, so we're gonna see what's up, man. We're gonna feed the wall.
Mate, this is gonna be a plasma. This is gonna be a plasma reactor. When this starts arcing off, it's gonna be like.
It will. The whole room smells like ozone.
It's Abha coil, making free energy.
And how much free energy can you make out of something that's
5 times over unity.
5 times
over unity. So 5 times.
5 times what something would be normal.
Yeah. So 5 times as much as you put in.
Okay.
It's safe to say 5.
Nothing else will do that. So in other words, apart from this, in those simple terms, putting in, getting out, anything you put in, you get out the same, right? Pretty well. But this is going to do it 5 times more. Would that be right?
Exactly, that's right.
And this is the only thing that
There's
can,
other things
that can put out more than it comes in.
No, there's quite a few different devices, but they all work off the same principle. You're an expression of one. There's lots of different living systems, and they all use the same basic geometry, which is what is being described here.
Okay.
Marko, can I quickly explain the rest of this structure to you? And maybe George as well, because I just wanted to get
I want to start over and we'll do it alone.
You know what,
I
I
don't want to
think
drag
George-
Daniel through it or anybody else.
Okay.
Daniel, when are you supposed
Yes.
to go to, when are you going to bed?
What am I? Well, maybe a little earlier tonight.
I got up last night reading the scriptures. Man, I almost felt sick this morning when I woke up. Anyway,
I'm going to speak to George because I think he wants me to. He's going to explain something to me.
So, Marko, are you going to be available in the morning too
yeah,
for that call?
yeah.
Okay, so I'll definitely be there 11 o'clock my time.
Remember that these are very wealthy people. And so they tell us what to do. We may think we're in the driver's seat, but we're not. And that's an understatement. So be very clear what your goals are, what you hoped to accomplish, and keep your position. And that's about it.
Sounds wonderful.
Okay.
Yeah, I'm pretty resolved in my goals, and I think I know where my intentions lie. So I think everything is going to work out just right. So it sounds good.
Well, Steve happens to be one of the most powerful persons in Los Angeles. I would say he's in the top 5. He controls billions and billions of dollars.
This guy here with the blue glasses.
No, Steve, who we're going to be talking with in the morning.
Okay.
Stephen Annenby. Stephen has a direct link into the universities, UC Irvine. Him and his business friends have contributed his gifts, hundreds and hundreds of millions of dollars. And that was my request, was to try and get a building and a location and a research project going. The thing is, it's very hard to keep the reins of control of anything. Just as soon as I think I have them in my hands, they're pulled out. So it's really, nothing's in my control, even if I am fantasizing that it is. And, but Stephen is in a, his position is he's going to want a large share of whatever he does. That's how he does things. And it's smaller than venture capital, but venture capital wouldn't even touch this right now because they have to have an IP. Bringing them up to speed is very difficult. Stephen's up to speed. He's ready to go. I've been working with him for 6 years, and George was 6 years. And Stephen believes. He understands. But, unfortunately, they only think in terms of what their return is. And so it's very, very difficult.
I think we could make it in a way that everybody could benefit simultaneously. I think there are enough avenues that could be opened, with still catering to the open source environment and still catering to the people who want to make a little profit on
You're
it.
more optimistic than me. You really are, to be honest with you. I'm probably as unhappy or fatalistic or pessimistic as could be right now.
We balance each other, Marko. We
Say-
balance each other. That's the way it's supposed to be, right?
Okay, I hope so. Every morning I wake up and I'm just swimming, trying to get past those waves, and the water's going over me in my dreams and stuff. So I'm not doing well. Okay.
We gotta get that coil pulsing over there, Charles.
It's pulsing. It's pulsing.
No, I mean a bit more harmonically, like amplifier, magnet.
Yeah.
Get some solfeggios in there.
My old friend Dan Winter always wanted fuzzy, warm feeling coils.
Euphoric coils, right?
Dan's been to stay. Dan's come to stay at ours.
Yeah,
You see.
I've known Dan for 25 years.
He thinks the moon is a Death Star, though.
I knew Dan when he was a young kid with black hair.
He thinks that the moon is a Death Star because he's got the crystal castles on the other side.
No, because he's got grey hair now. He's angry.
Okay.
Dan believes in aliens a lot.
I believe in aliens. There's nothing wrong with that.
I said a lot.
So do I.
Oh, yeah, really? Who is it? Who's there? Anyway. Have you met Venus? Oh, there she goes. Never mind. So, I guess just remember when you're meeting these other people that nobody's doing things benevolently, okay, or altruistically. It's because they're heavy hitters. Controls everything. Can control anything. Do anything. We can't even comprehend it. Okay. When I was out at his house one day, 6 years ago, across the bedroom, side by side, was Sony 55-inch TVs with the stock market. And we were supposed to meet a couple of days later, and he called up and canceled. He had lost $150 million in stock fluctuations. And he made it back later on next week, but by then I already left. Then I've been over to his house. I went with Jen, who was actually Horowitz's manager at the Steam Van Inn, and then I went with Oceana, and then I met with Steve at the Coral Tree restaurant, and he explained the math to him, went over everything. And his background is math, analytical investment, stocking, and he controls more money than we can imagine. When I say billions, I mean billions and billions.
Hundreds of millions.
And so he got it. I gave him a very thorough, deep. I showed him that numbers had mass, they have volume, that there's dimensionality to numbers, and I went in length with it. And so it's pretty much everything's a done deal, and that's not what the problem is right now. That isn't what I'm having a hard time with. The problem that I'm having is that I wanted to create a company where all the income, the net, went to the environment. And it went to either reforestation or education, but it isn't happening.
I've got the plan right here.
You may have the plan, but the figures you're talking right there aren't even on the radar with what they talk about. They're so much bigger and greater.
But
Their power.
Yeah, but
and besides, if they give Daniel money, if they give you money, if they give me money, we're willing to take money. We all need money, but nobody's really come up to the plate because for some reason we haven't been able to penetrate. Yeah. If you think you can penetrate, I'm not trying. But this is what
penetrate into organizations like this with that kind of power.
penetrate. If you can get your people to give us money, unrestricted, free gift, that would be wonderful.
Yeah, that's the whole thing. It's a donation.
Well, you should be on the phone with them now.
Tonight, 10 o'clock is when it's organized.
Yeah. Well, I'd like to talk to people privately because I have trouble listening to other people and people talk.
All it will be is each person introduces himself and what they're doing just for communication, and then everyone's heard each other in the group and they know who they all are. That's it. And then it's.
You don't know what my personality is. My personality is I avoid. I try and keep an arm's length from everybody and everything. I didn't patent my work. I didn't put a copyright on it. But I have a lot of trouble getting sucked into things. One of the few people that I'm willing to do anything with is Randy, because we're personal friends. I've agreed to do a cameo in his movie, but I've not agreed to...
I heard about that, Marko. This is going to be cool.
Well, if we got out of his way, it could be a cult classic, but seems we're all blocking his success right now. Oh, you're coming too, I forgot.
Yeah. That's gonna be cool. We'll have a little feature role in the film and rip apart some copper and put together a coil and.
When are you coming?
He gave me the rundown last night.
When are you coming? How soon?
I'm not sure. I haven't been told for certain, but whenever. I'm just up to make the moves. You know, it's about that time. You know.
Well,
I'm ready to let go of the fear and just move forward and start making this stuff happen. It's about that time.
There's some lemons down there.
Well, that's what life's about. Life's about getting rid of any petty paranoias, you know, and not caving into what your ethics and morals are, you know. But
Ethics and morals are just perceptions, right? Instilled by us.
no, that's not true. The ethics and morals are applied from one world to the next. They're like divine touchstones. A good one would be compassion, okay, or tolerance, forbearance, or you know. I mean, he's trying to found a company on. He calls it a harmless company. But I hate to say it, but you know, you can't micromanage the world. They're going to do with it whatever they want.
With the world, yeah, but for ourselves, we have a
So that's all we
responsibility.
care about is for ourselves. I agree with you there.
And you birth the child. You know, you birth the child, and whatever happens as a result to that birth, you know, it's kind of out of our hands. But we just make sure that we're birthing the child at the right moment. That's something that I've come to understand after coming back from our journey from California last time. Had quite some experiences out there with people trying to sue us and slander us and a bunch of craziness, man. I mean, at the end of the day, you realize that, you know, you birthed the child.
Did you get any letters like that, threatening letters?
Oh, yeah, I've got the
You gotta
nastiest
frame them.
emails.
You gotta frame them, put them up on the wall.
Yeah, no,
Yes.
you know what? I don't want to carry that with me. I'll leave it in the past, and I'll learn from my experiences. But, you know, I don't take that with me because, you know, to remind myself of that every day is not exactly the right vibration that I want to carry. So, you know, I think moving forward,
Daniel, you know you would be doing much better if you wrote a book on what you're doing and you had a book to sell. If you came out with one with illustrations, documentation. Reason is that then you can go on. You can be a guest host on Coast to Coast, a guest speaker. But until you have a book or something like that, it's called golden when you have a book. Now I don't have a book, so it doesn't seem like I know what I'm talking about. But that's what it takes, because that opens up tremendous different avenues to it.
people don't even watch the videos, Marko, let alone a book. You think they're going to read it?
No, but trust me, you would be on Coast to Coast, you would be on TV shows, everything. Trust me, it would make a huge difference.
So I've got to start writing. I mean, with what time, though? You know, it's like you either make the coils or you write the book.
Other thing is if you're soldering in your house, you got to be real careful with the baby. That's lead-free solder or whatever.
Oh no, we've got the lab now, so it's a lot better. And when we're testing now for this high voltage and we start producing ozone, you know, we're not in the house anymore, so that's perfect.
Yeah, that's what I was wondering about.
Yeah, no, he's not around. He's not allowed in here when testing is going on.
Okay.
But thanks for that, Marko. Yeah, for sure. I know you remember we used to do this in the basement, on the floor of the basement. Oh man, permanently magnetizing scissors, blowing coils and stuff. Marko was like, "Listen, you got to get that out of the room."
I don't even remember that far back now.
Yeah, that was what, 3 years ago, Marko.
You know what I said? You know, my mind's getting real bad. My memory's real bad now. My favorite saying, though, I still remember, which is, the first thing that goes is the mind. So, I'm really beaten to the ground. I'm really tired. You know.
It's the last bit, though. It really is.
Okay, so thank you to everybody.
Thank you, Marko. It's always a pleasure. For sure. I think things are picking up, and I think the synchronicities are a lot better. I wanted to ask you, is Tyler still your manager?
Well, he was my point person on one thing, which was for for 6 videos. I asked him a couple weeks ago. I said I'd pay $500. I said I needed these quick, like 1-minute videos, because all the people who know how to do it are real talented. They're all doing something else right now. Me and Tyler and Freed and everybody, there's not one person that I didn't break away from, that we didn't go our separate paths. And the thing is with Tyler, the reason I broke up with everybody is not normal reasons, to be honest with you. The reason is I couldn't pay him. And since I couldn't pay him, they were all making big sacrifices for me. And it was a big hardship on them, their family and everything. And, you know, we had Brad commit suicide. Remember that? I don't know if you know about that.
I think so. Yeah, I remember.
I had Lucy overdose on acid. It was just one problem after another. And so I just said, everybody's on their own, everybody's doing their own thing. Tyler and me will always be very close. Everyone has trouble with Tyler. The trouble they're having, though, is mostly over money at this point. Money or control, or he's acting like he's a rep for everybody and selling other people's products, this and that. But I really think that his motivation is true. And I think that he has done a lot of damage to himself, but most people don't know him as well as I do. Okay? So you have the same problem as him. You have a newborn child and you have a spouse. Okay? My girlfriend just broke up with me. I can't tell you, and she's pregnant. She's 15 weeks pregnant now. I'm 57, she's 27. It wasn't an easy relationship to begin with. And she's also, very creative. She's a singer, artist, this and that. And my stuff that I'm working on tends to be very, very dull a lot of times. So anyway, but the thing is that he recognizes that he has to take care of his spouse. His mother has come up to where he's at, and his mother-in-law as well, and they've all gotten on his case. I know you're not making enough money to justify what you're doing at this juncture. I know I'm not. Nobody is. I think we're all walking in towards taking tremendous losses down the line. I don't see light at the end of the tunnel. I know Charlie does, but I don't. Certainly these people can perceive hardware. When they see the lights, you're refining your presentation. When you can say this is apples to apples, this is A to A or A to B, and this is what it is.
Okay, I'm coming.
I didn't know your baby was that old now.
Don't tell mommy I'm coming now.
Let's see.
Look, you want to say hi to Marko?
Hi.
Hello. What's your favorite pie or ice cream flavor?
What's your favorite ice cream? What flavor?
Chocolate ice cream.
Chocolate ice cream.
I love chocolate too.
He loves chocolate ice cream.
I love chocolate everything.
Chocolate ice cream smoothie.
Smoothie. Chocolate ice cream smoothies.
Okay, I'll have half. I'll share it with you. It's a pleasure meeting you. My name's Marko. I'll see you again.
That's Marko Rodin.
Yeah. You know who I am? I'm the guy who studies on the numbers with the name of God and says the weird sounds. Want to hear a weird sound? Listening? How is that? And when I was a little kid, I used to make watch.
That was good.
Yeah.
Nice. All right, tell mommy I'm coming. Okay?
Have you seen Lilo and Stitch?
Have you seen Lilo and Stitch?
Yes.
Yes.
Oh, I love Lilo and Stitch. Okay.
My favorite animals in the zoo.
His favorite animals are in the zoo, and he likes
Lions and bears and giraffes.
lions, bears, giraffes, and
Bears.
Those are pretty big animals.
Yeah, he likes the big ones. He skips the little hamsters and stuff like that.
Oh.
Right?
Cool.
You like animals? All right. Well, tell
I'm
mommy
gonna-
I'm coming, okay?
I'm going to send your dad a video. Wait, tell him one thing. Tell him you'll have a video for him for bedtime tonight. You're going to get one for him. I have a movie. I'm going to send your dad a movie to watch, for you to watch before you go to sleep. It's called The Trunk Monkey. Ask him before you go to sleep, I want to see the trunk monkey. It's a chimpanzee. Okay?
You want to see the chimpanzee movie? Okay,
Trunk monkey.
Marko's going to send it now. So I'll show you
Can
before you
pull
go
it
to
up
bed,
for me
okay?
right now? Okay, go to YouTube.
Okay.
Type in trunk monkey. We're getting it for you right now. Just give me 1 second.
Tell mommy that I'm coming now, okay? Yeah, it's dinner time. The messenger has come to grab.
Trunk monkey.
That's one thing.
There's one thing. Okay. Hold on, guys. Hold on 1 second.
We're getting it for you. It's okay. Hold on. They're all so funny. But wait, let's get a real long one. 503, 635. See what happens with the compilation. Yeah, we'll take that one. So let's cut and paste that whole thing. We got it coming for you.
Marko.
You don't like the way I drive? Why don't you come on in here? I'll give you a driving lesson. You want a piece of me? Why don't you come out?
Give us 1 second, Daniel.
Where are you gonna go now? Well, you can't speak.
Me and Charlie are watching.
Now you think you're better than me? Well, you think I like the way you drive? What are you gonna say? Keep out! The Trunk Monkey, a revolutionary idea you'll only find at Suburban Auto Group, pending approval by Attorney General.
All right, back in the trunk.
You guys. All right, guys. Listen, I've got to go run for dinner now. It was nice chatting with you guys. I'll be available in the morning.
Okay, very good.
Okay, cool, bro. Here's a playlist of lots of different examples of people working with the big predators through love, like best friends with bears and wolf and lynx and stuff like that.
Say hi to Daniel. Daniel, do you know my little girls?
Hello.
This is Venus and Cloud.
Hello, Venus and Cloud. I'm
Say hi.
Daniel. Pleasure to meet you.
They're 11.
Guys, so we'll talk later then. If you need anything with the circuit or anything, just drop me a line.
It's singing, bro. It's singing. I got to work out a load, but I'll figure that. Do you think I can plug this on now? We've worked out the circuit, or was it that was stopping it from working?
Yeah.
Yeah, give it a try. Give it a try. It might have just been before that you blew the transistor. So just give it a try, and it should work.
Okay, brother. All right. Have a nice dinner. Love to everybody.
You too, bro.
Okay,
Talk to you
bye.
later.